Okay, we're going to try and find the complete solution of the second order non-homogeneous equation. We have the second derivative plus 1, parentheses closed, times y equals e x to the sine of x. So I like to rewrite that as second derivative of y plus y equals e to the x sine of x. Then we can even write that as y double prime plus y equals e to the x sine of x. And so that we can find our roots, we have to set it up into a homogeneous equation, which would be m2, 2 being this order or derivative, plus 1. Set that equal to 0. Then we have m squared equals negative 1, which gives us the roots 1i, positive negative 1i. And then we can use our chart here that shows us. See, we have a conjugate. We have two conjugates in this form over here. M1 equals P plus IQ, M2 equals P minus IQ. And our P would be 0, and our Q would be 1. And then from the chart, we have to rewrite it in this form for our characteristic equation, or our general solution. And that is y equals e to the px a cosine q of x plus b sine q of x, p being 0, and a cosine 1x plus b sine 1x. Okay, and that just simplifies to, that'll become 1. We just have a cosine x plus b sine of x, yc, and that's our yc. And the complete solution would be y is equal to yc plus the particular solution. And now we just got to find our particular solution. And we'll go back to this chart, this other table here. And we have to look at our second, the other side of the equation, our second function, e to the x of sine of x, and try and match it to the chart. And it looks to be number 7, and we don't have an a to the x out in front of our e to the x sine of x. It's just e to the x sine of x for us, so we can, where our r is 1 and our k is 1, so that simplifies to this. We can get rid of all these constants with variables, and we're left with just this one constant, a to the n and b to the n. So that goes to this format. A e to the, since our r is 1, x, we just leave it e to the x, cosine, and since our k is 1, we'll just leave it as x, plus b e to the x, because our r is 1 still, and our k is still 1, sine of x. And then I'm going to factor out this e to the x. We'll have a cosine x plus b sine of x. And then we're going to want to plug this back into our original equation up here. So we're going to have to find the second derivative of this function. So we have this as our particular solution. Now we need to find the first derivative, which is going to be e to the x derivative, which is just e to the x, plus e to the x, the same, then derivative of this function, which is negative a sine x plus b cosine of x. Now the second derivative is going to be almost the same thing, derivative of e to the x. A cosine of x plus b sine of x plus e to the x, a sine of x plus b cosine of x. Second part down here, e to the x, negative a sine of x plus b cosine of x plus e to the x, a cosine of x minus b sine of x. Okay, now I'm going to factor out this e to the x. We have a cosine of x plus b sine of x minus a sine of x plus b cosine of x minus a sine of x plus b cosine of x minus a cosine of x minus b sine of x. Then we just combine like terms or cancel them out, and we can cancel out that b sine of x, and we can cancel out this a cosine of x. Then we just have 2b cosine of x minus 2a sine of x e to the x y. Okay, now we're going to replug it back into this equation. So this is our y double prime plus y, which is just our underived function, e to the x, a cosine x plus b sine of x, and we'll set that equal to ex sine of x. Okay, so now let me factor out another e to the x. And then we have 2b cosine of x minus 2a sine of x plus a cosine of x plus b sine of x and then I'm going to combine the signs and factor out the signs, and combine the cosines and factor out the cosines. So we have sine of x be minus 2a then if I factor out a cosine of x here, I'll have two b plus a equals to e to the x sine of x. Okay. Let me reapply this e to the x. B minus 2a plus cosine e to the x cosine x 2b plus a. Rewrite this step, it's messy. So we have e to the x sine of x b minus 2a plus e to the x cosine of x 2b plus a ex sine of x. And now this, we're trying to make this an identity, and this would be an identity if this b minus 2a will be equal to 1, because we want it to look like the right side. And if that's 1, that'll just be e to the x times sine of x. And we don't have a cosine of x or e to the x attached over here, so we want this to completely cancel, this whole term to cancel out. So what can we make this, these constants, so that this whole term will cancel out? Well, that has to be equal to 0. So 2b plus a is going to be equal to 0. Now we have a system. So once we've written up these identities, b minus 2a equals 1 and 2b plus a equals 0, we can solve the 2 and say b is equal to 2a plus 1, and then plug that into this equation, or to the second equation. So it'll be 2a plus 1 plus a equals 0. And we have 5a plus 2 equals 0. So a equals negative 2/5. And then if we plug that back into this equation, we get b is equal to negative 4/5 plus 5/5, which is just 1/5. And then if we plug this into our particular solution, which is e to the x a cosine of x plus b sine of x, we get e to the x negative 2/5 cosine of x plus 1/5 sine of x. And then for a complete solution, we just add the characteristic solution with the particular solution, and our characteristic was a cosine of x plus b the sine of x, but we're going to leave a and b as variables so we can notate them differently since we're plugging in a and b to the particular solution. We'll call a c1 cosine x plus c2 sine of x, and then just add it on to our particular solution, 2/5 cosine of x plus 1/5 sine of x. And that's our complete solution.